¿Qué tal? Buen día. Today we're going to clean up some of the naming, variables, and parameters passed to a few methods. Nothing will be terribly intellectually challenging, but we will modify quite a few files. If you find this boring, feel free to check out the code in the GitHub repository included in the description, and you'll be ready to follow along next time. As a reminder, our repository has a branch for the code at the end of each tutorial. In this case, that would be lesson-11. Our service and repository factories return interfaces. As an example, let's look at the user service in service, user underscore service.go. We want to make sure that other packages use the factory and its accompanying config to instantiate the services in repository. And in this case, this is the factory, new user service, which receives the US config as a parameter. We do not want the user to be able to instantiate the service directly by setting up the user service struct. To make this change possible, we'll make the user service inside of the service layer, not inside of the model layer, package private by making it lowercase. And I'll just add the comment here. Since we make this struct lowercase, we need to also update all of the receiver methods to use this lowercase user service. So we see we have a get method and a signup method, and that's it. So I can just multi-cursor here and maybe go to U and change and save the file. We have a problem, undefined user service, and of course we need to make sure that we return the lowercase package private user service from the factory as well. Let's go ahead and do the same thing for the token service by going to token underscore service.go. We'll make the token service struct package private. And we'll go down and make sure to return this updated struct. And then also update the receiver methods here. And I think this is the only one we have right now. That's true, so let's save the file and make sure there are no problems. Should be good to go. The last implementation we need to update is in the repository layer, and that is the Postgres or PG user repository. Let's scroll to the top. Let's change this to PG. Maybe I should make these both lowercase. That's your preference. Return the lowercase. And we have two receiver methods, so I'll just highlight these and change these both to P. If I save, all right, doesn't look like we have any problems. I now want to open up the terminal and CD into the main project root folder, and we're already there in Memriser. That's the top level folder above the account folder. And I want to run Docker Compose up just to make sure that all our dependency injection is working. It looks like all of our services inside of Docker Compose started, and that our Golang account application is running with the handlers. Another change I want to make is to the context that is passed down the call chain from the handler all the way to the data sources. To do this, though, we need to extract the request context from off of the Golang context. We do this to the service method calls inside of handler layer methods. We need to update our two current handlers. If we go to handler here, those are signup and me. Let's first go to me.go. Here is our handler function, and let's scroll down, or method I should say, it's on the handler struct. And here you'll notice that we pass the Golang context C if I hover over this. Actually, that doesn't give the package, but it is from the Golang package. We want to extract the request context, which we'll be modifying in middleware, and forward this on to the user service. Here is the necessary change. We extract the request context using this helper method from Golang, and we then forward this to our get method. Let's go ahead and make a similar change inside of signup.go. Inside of signup.go, we need to make an update to both the signup call here and the new pair from user method in the token service. To do so, I'm just going to extract the request context from the gen context and pass that to both of these methods. Now that we do this, we're going to have some errors inside of our handler layer test files, the me test and the signup test, because our mock implementations of these services are expecting to receive a gen context right now. We want to make sure that these are able to receive an empty or a context.background, which comes from the Go context library. First, let's go to me_test.go. And what I want to do is find any of these calls that say mock anything of type gen context, and I'm going to just Control D. I think this is the only one in the me handler test. That's correct. And what we're going to do is change this here to a reference to context.emptyctx. And this emptyctx is just an alias for context background, meaning a non-nil empty Golang context. Let's now go to signup_test.go and make the same change. Here we are. And we do use this in a few cases here. There's also one at the top. And so let's just go into all of these and say context.ctx empty, empty ctx. It turns out I forgot to change a couple of the mock anything of type gen contexts to context.empty context. So really make sure you find all of these in both the signup test and me test, and then you can go ahead and make sure your unit tests are still passing in the handler layer by running go test, verbose, flag, and handler layer. Let's see if this works. Alright, the tests for this layer are passing. I also want to use methods in SQLX that can receive the context. To do this, we'll update method calls on DB in the PG user repository to use context versions of each method. As an example, let's open up this PG user repository and see that there is currently a create method that calls rdb_get. We want to change this to get context. And this takes as a first parameter the context, so we just need to forward ctx there. And then you also want to make sure to do the same thing inside of find by ID. So let's use get context and pass ctx. I also want to make some changes to our environment configuration. To make our app more configurable, I want to update the following. I want to pass the app API URL, which you can find in the .env.dev file. I want to pass this into our handler.config. This way we can instantiate the handler with this base URL inside of the main package. I generally like to load the environment variables inside of the main package so that we can catch any problems in the environment when launching the application and then crash if there is a critical problem. Let's go to our handler configuration here in the handler folder, handler.go. And let's add this property as a base URL to the config. And this is just a string. Now that we have this base URL on our config struct, we can go down to the new handler factory and update this call to get environment with the base URL. The config is C, so we should have a base URL. We now need to read and pass this environment variable to the new handler inside of the injection.go file. This injection.go file, if you'll recall, is part of the main package, and it just instantiates all of our concrete implementations of repositories, services, and the handler. We do this towards the bottom where we instantiate the handler. Let's read in the base URL here from the environment variables, and let's go ahead and add it as the base URL. And add the trailing comma. I also want to mention that We are instantiating this handler inside of our unit tests. In other words, we're calling this new handler method, but we don't need to make any changes because using the base URL as an empty string or omitting it will make the base URL an empty string, which is just fine for our current unit tests. I also want to make some changes to our JSON web token expiration duration. We currently set the JWT expiration with hard-coded values inside of token utility methods. That's in this service tokens file. You can see that we're setting a hard-coded value of 15 minutes for the token expiration here. I want to make these functions configurable, so let's also add environment variables inside of the .env.dev file. I've added a refresh token expiration here, which is the time in seconds equal to 3 days, and an ID token expiration with 900 seconds, which is equal to 15 minutes. We'll read in and parse these environment variables in the injection file, as we did with the base URL. But first, we need to add these timeouts to our token service config, which is called tsconfig. Let's go to the token service, scroll all the way up to this config, and add these two fields. Here are the newly added fields. We add them to the token service struct here. We also add them to the config. And then we instantiate the token service with these values from the config here. And these are called ID expiration secs and refresh expiration secs for seconds, not for... Anyway, let's now update the instantiation of our token service inside of injection.go. I have a lot of files, but here it is. Let's go in the file to where we instantiate our token service. And right here, let's go ahead and load in those environment variables. Notice that to load in these environment variables, we first use os.getEnv to get both of them, and then we need to parse these to an int64. And since we're parsing to an int64, we should check for any errors and crash the application if so. Then we'll add these to our token service factory. We save the file, and it looks like there are no errors or warnings. The final thing we need to do is accept these values in our utility functions for generating tokens. This can be found in that token file here, or tokens file. Let's add a third parameter to this generate ID token function called exp. And this will take that int64. And instead of hard coding this 60 times 15, let's just use exp. Let's go ahead and make a similar change to the refresh token function here, or generate refresh token function. Let's add an exp parameter. And to add to the time, notice that here we're using a time or duration from Golang's time package instead of just the actual number of seconds. Let's update this method addDate to use the current time and add a time in duration, not in days. So instead of using addDate, we're just going to use current_time.add and multiply this duration by seconds. And we have to do this casting from int64 to duration so that this method will work properly. But durations are actually just stored in int64, so that's an easy cast. We should have some warnings or errors now because we're not using the proper number of arguments when calling these functions in the token service here. Let's go ahead and update that. Here is our call to generate ID token, and let's add the configuration field for ID expiration secs. And we're not loading this from the configuration because this service has already been instantiated, so this should be an S from this S in the receiver method. So let's fix the last one. And we should be able to pass to this function s.refresh token. And that's actually just refresh expiration seconds. Okay. Good, all our problems have disappeared. Well, at least our problems with this token service. Furthermore, we'll need to update the expectations in our token service test. Let's go to token_service_test.go. Let's go to the top of this file. And we'll hardcode in these expirations for our unit test. We could also try to load them in from the environment or have a test environment. I'm just going to add them here. Here are the two variables we've added in, making sure that they are int64s. And then we go down to the new token service or instantiation of the token service and add the parameters ID expiration and refresh expiration. We can then use these hard-coded values to update our expectations or assertions for the expiration time. Here is the expected expiration time for the ID token, which we have hard-coded at 15 minutes. We can change this by doing the following. We'll use the time.now and then add a duration of this 900 seconds int64 as seconds again. So we're changing this into a duration. Let's go ahead and make a similar change for our refresh token. If we scroll down, here is the current expectation. And now it's using that refresh expiration variable we set at the top. So this is getting pretty tedious, but there is one more thing I want to do. Our struct tags for our model.user and model.token pair only accept JSON. Currently, when we bind data with our bind data function in the handler layer, let's look at that. We might receive form or XML data in the HTTP body. I want to make sure to send a clear error if the user sends anything other than application JSON. Let's add some code in the handler bind data towards the top of the bind data function. And by towards the top, I mean absolutely at the top. We'll check the content type using the genContext utility method here. If the content type is not application JSON, we're going to send a message saying that the full path, Gen provides this as a utility method as well, only accepts the content type application JSON. However, I want to send this error as an HTTP status unsupported media type, but we don't currently support this in our custom app errors. We don't need to create a custom app error for this. It might be overkill, but I'm going to do so. Our app errors can be found inside of the model folder, app errors, and apperrors.go file here. The first thing we'll do is add a const to hold the string name unsupported media type. We then have this receiver method to parse a status, and it's just a switch case, so we need to add the case if we receive unsupported media type to return the HTTP status code from the Golang HTTP package. Finally, let's go to the very bottom and create a factory helper method here or function to create this error. And this is the function that we are calling inside of bind data. Let's save this file. Let's go back to bind data and save this one as well. And hopefully everything looks good. And in fact, we don't need to call this HTTP status unsupported directly. We can say error.status using those helper methods inside of our custom app errors package. Let's try running this application and opening up an HTTP client to see if this error works and if our application generally works. Let's go and run docker compose up. And in fact, let's cd to the root folder. All right. It does look like our Gen account has set up properly, even though we had these earlier errors starting up Postgres. I'm not 100% sure why that is. I'll need to look into that. And even though we have 1 million logs, it looks like things are running. So let's open Postman. I've cleared out the database from last time, so we don't currently have any users. Let's go ahead and try to sign up a user, which is basically our only functionality right now that's fully functioning at least. And that looks good. We receive our ID and refresh token. Let's try to send form data now. I've prepared a new user called Guy02 instead of Guy01. So let's go to form data. And so this should be a valid user, but let's see if we get that error we just created. Great, we get an unsupported media type with a response status of 415. Now I want to run the unit test for the application just to make sure none of the individual components is broken. Let's shut down our Docker here. We'll change directories back into account because that's where our unit tests are. and we'll run go test. And we'll use verbose flag, and to run all the tests and all the packages, we can do /:::. And all the tests that at least exist are passing. Let's go ahead and run that without the verbose flag. I need to maybe test these individually. It's a little much to read. Let's just see if we get an OK. And we do get an OK for at least the packages that we are currently testing, the service and handler layers. Hopefully a few of you found this useful. As a reminder, you can also go ahead and check out the code for the Lesson 11 branch on GitHub to have these updates. Next time, we'll get working on a token repository. Hasta entonces, chao.